So last week I introduced to you the idea of functions, which was an idea that you were already familiar with. The main new stuff that we learned last week was what is a domain and what is a range. So if you've forgotten those from last week, definitely look those up before we start today. Today we're going to move on to the next part of functions, which is called composite functions. But before we start that, here's a quick starter just to remind you of what we did last week. So have a go at this one. And on the next slide, I'm going to go through the answers. Okay, so let's go through the starter then. So we've got a function which is named f of x, and the operation is 4x squared add 3. So whatever numbers you put into the function, you just square them, multiply by 4, and then add 3. Now we're given a domain, which hopefully you remember is just a fancy word for an input. So the numbers that we're allowed to put in are real numbers. So remember, this notation says x is a member of the set of real numbers. So it can be any positive, negative, fraction, decimal, integer, any real number, but we're limited to numbers between -3 and 4. Now we've used the bracket notation for this one. We've got a curved bracket on the -3 and then a square bracket on the 4. So it's really important that you remember what those different types of brackets mean. The curved bracket means that we do not include -3. So it's everything above -3, so minus 2.9999999 upwards, but it does not include the -3. And from there we're including every single number, every decimal, all the way up to 4. And we do include the number 4 because the square bracket means that that number is included. So if you did want to write this in inequality notation, it would look like this. X is between -3 and 4. We include the 4, which is why I put the equal sign on that inequality. But I'm not including the -3, which is why I did not put an equal sign on this first inequality. Okay, so the question is find the range of this function, and the range is just a fancy word for what are the possible outputs. So when we put these numbers into the function, what could we get out? Now I gave you a couple of tips last week for how to do this. Something that's really useful to do is to put the numbers from your domain into the function. So something that would be helpful to do first would be to work out f of -3 and f of 4. So here you can see I've put those numbers into the function. I put -3 in first, square it, times by 4 and add 3. That gives me an answer of 39. And then I put the upper number, which is 4, into the function. 4 times 4 squared, add 3 is 67. Now sometimes that gives you the range straight away, but not always, so definitely do a little bit more investigating. Another tip that I gave you last week was to investigate what 0 would look like. So if 0 is in your domain, which 0 is included in our domain, then usually something interesting is happening there. So if I work out what's going on at 0 by putting 0 into the function, 4 times 0 squared add 3 is equal to 3. So that's interesting because from the first two lines that I did, it looked as though my lower limit might have been 39. But now I can see that the lower limit for my range is definitely not 39 because now I know that this function goes down as far as 3. The other thing that I said was really useful to do, if possible, is to sketch a graph of the function. Sometimes you get given a complicated function and you might not know what the graph looks like, but if it's a graph that you know the shape of, then definitely draw it, because that will help as well in finding your range. So this is a nice easy one to draw. Obviously we all know what a quadratic graph looks like. So if it was just x squared, it would be a U-shaped graph. This one is 4x squared, which means that it's going to be a taller graph, stretching upwards more quickly. But it's got a +3 on the end, which means that the U-shape would all slide up 3. So the graph would look something like this. So it's the x squared U-shaped graph. It's been stretched upwards by that 4, which doesn't really matter in a sketch too much. The key bit here is this plus 3, which means that it's slid up 3. Now, having that picture, or first of all, I should say I've drawn the picture only from -3 up to 4. Never draw more of the graph than you need. If you draw the graph and then you realise you've got too much drawn, always rub out the bit that you don't need. But this one, I'm only drawing the graph from -3 up to 4. So I know from my workings earlier on that at -3 on the x-axis, I'm at 39 on the y-axis. But from 4 on the x-axis, I know that I'm at 67 on the y-axis. So now I look at the graph that I've got, and I'm looking at the y-axis, because remember that inputs and outputs are like x coordinates and y coordinates. So I'm now looking at the y coordinates, and I'm thinking for this graph, what's the lowest value it hits on the y-axis, and what's the highest value it hits on the y-axis? Well, I can see that the lowest point it comes down the y-axis is this point here, which we know is at the number 3. And then the highest point it would reach on the y-axis would be this point here, which I know is 67. So from my picture and from my workings earlier on, I've worked out that the range of this function is from 3 up to 67. So my calculations earlier were helpful, even though the 39 didn't come into it in the end. All of the calculations that I did earlier were helpful. The picture of the graph was definitely helpful, and that's helped me to work out that on the y-axis this graph goes from 3 to 67. Now the last bit to point out is the type of brackets that I've used. So I've chosen to use square brackets in my answer, which means that I'm including the numbers 3 and 67. Now the way to make that decision is to decide, does your graph actually hit those numbers? If you know that your graph definitely goes through those numbers, then you can put the square brackets. But if your graph would approach but not quite reach those numbers, then you could use the curved brackets. Now on this one I can see that the graph definitely goes through the number 3. So that point that I marked there with the purple dot, the graph is going through that point, it is hitting the number 3, it definitely reaches the number 3 on the y-axis. So that's why I've put the squared bracket around the 3. Then with the 67, as this graph comes up, I need to decide, does the graph actually hit 67 or does it stop just before it? Well, I've decided on this one that it does hit the 67, and the reason is that if I go back to the domain, that number 4 had a square bracket around it, which means that along the x-axis we do go as far as 4. We don't stop just in front of it, we go all the way as far as that 4, which means that we are allowed to include 4 in the function. So if I go to its corresponding point on the graph, which is at 67, we do include that in our range. So I put a squared bracket on the 67 as well. Okay, so here are the learning outcomes for this chapter on functions, and we've ticked off quite a few of these already. So last week we understood and used the definition of a function, we talked about domain and range, and we talked about this one-to-one, one-to-many, many-to-one, etc. Today though I want to focus on composite functions. So the bit that the box is around, understand and use composite functions, and then know that fg of x is equal to f of g of x. Those are the things we're going to talk about today. So you probably came across the word composite when you were back in school, probably in the context of finding areas. So you would have learned how to find areas of simple shapes like rectangles and triangles, for example. And then you would have probably moved on to more complicated shapes like this one, which your teacher would have probably called a composite shape. So a composite shape is a more complicated shape that's made up of 2 simple shapes stuck together, or it could be 3 simple shapes stuck together. So these are the sorts of things that you would have seen before, composite shapes, which are two or more simple shapes stuck together. Now exactly the same principle applies with functions. Composite functions are where you've got two or more individual functions that are basically being stuck together. So here are some notes on composite functions. You can combine two or more functions to make a new composite function. So in this picture, for example, we're starting off with a set of numbers, which we'll call x. These are our inputs, numbers that we're putting in. And first of all, the first arrow going across has got the letter g on it, which means that we are doing a function which is called g of x. So the answers that we get out will be whatever we get when we put the x values into the function called g. So we've done this g of x function. But after you've performed that function, you could then perform another one. So whatever you get out of this function, you could then perform another function. So let's give it a different name. If it's a different function, let's call it f. So we've done f to g of x. So the notation that we would use there would be this, fg of x. So fg of x means that we are, first of all, performing function g to the x numbers, and then we are performing f to that. So you can see there that the way that it's written is actually in the opposite order to the way that it was performed. Fg of x means that we do g to x first, and then we do function f. So even though the f is written first and then the g is written, we perform it in the opposite order. So we would do g first of all, and then we would perform function f to that. So the note underneath, fg of x means apply g first, followed by f. Fg of x is called a composite function. So we're going to go through some examples of how you would construct a composite function. It's fairly straightforward to write down a composite function. I think the more difficult part of this is finding the domains and ranges. But we'll start off with just actually writing down composite functions. So this is an example then that I've taken from your booklet. It's on page 41 if you want to have a look at it later, but we'll go through it now in detail. So here we're given two different functions, f of x equals x squared and g of x equals x add 1. So if you wanted to put any number into the first function, you would just square it. And if you wanted to put any number into the second function, you would just add 1 to it. Now in part A, it asks us to find fg of 1. So we need to do both functions, f and g. And we're asked to substitute in the number 1. Now from my last slide, remember that the letters are always written down in the opposite order to which they are performed. So if we're going to do fg of 1, that means we need to do g of 1 first, and then when we've got an answer, then we'll perform function f. So first of all, let's just work out what g of 1 would be. So that means I'm putting 1 into the g function, which is going to be 1 add 1, which of course is 2. So I've performed function g, so I've done this part. Now I've got to perform function f. So whatever result I just had, I'm going to put into function f. So I'm now going to do f of 2. So f of 2 would be 2 squared, which is 4. So my final answer is 4. So fg of 1 is equal to 4. You haven't got to write it in two separate lines as I've done there. I've just done that to hopefully help you to understand what's going on. So let's have a look at part B. We're doing fg of 3. So this time, to save a bit of time, I'm not going to write out all the steps. I'm going to try and condense this down a little bit. So first of all, we've got to perform g of 3. We're doing function g first. g of 3. So I'm putting 3 into the g function, so I'm doing 3 add 1. So before I write down that the answer to that is 4, let's just leave it as 3 add 1 for a minute. So I've worked out g of 3. Now I need to perform function f. So looking at function f, that means that whatever result we've just got, we need to square it. So fg of 3 will equal 3 add 1 squared, which of course is 4 squared, or 16. So you can write it in one line like this. If you're not happy writing it in one line, go back to 2. So your alternative would be to work out g of 3 first of all, which would be 3 add 1, which is 4, and then perform function f to that. So f of 4 would be 4 squared, which is 16. So it's up to you whether you want to write it in one line or two, so whatever you're happier with. Okay, part C. This time, instead of being given a number, we're generalising and we're still using the letter x. We've got to write down what fg of x would look like. So x is what I'm putting into the function. I've got to do g first. So I need to work out what g of x is first. Well, that just basically means copying what I was given in the question. G of x is just x add 1. I don't have a number to sub in this time, so I'm just going to leave that as an x. Next, I need to do function f to that. So whatever result I just had, I need to perform function f to that. So looking back to what function f said, function f was square it. So whatever you put into function f, you have to square it. But this is what I'm putting into function f, so I need to square it. So my answer is going to be x add 1 squared. Okay, so here are some more examples. Again, they're from your booklet. This is on page 41. Hopefully on the last slide you found that substituting in the numbers was quite straightforward. These examples now are just a little bit more practice of, rather than substituting in numbers, keeping those x's. So in this one, we've got two functions. They're called f and g. F of x is 3x add 2. So whenever you substitute something into here, you're just going to times it by 3 and add 2. And then g of x is x squared add 4. So if you sub anything into here, you just square it and then add 4. Part A then, we've got to write down what would the composite function fg of x be. Fg of x, that's what we're asked to find. Remember that the letters are always written down in the reverse order. So for this one, I need to perform g of x first. Well, because I'm not subbing in a number, g of x, this part, can simply be copied straight from the question. So g of x on its own would be x squared plus 4. Now I need to perform function f to that. So whatever result I've got, which I've just written down, I need to perform function f to that. So I need to substitute that into function f. Now remember I said earlier that with function f, whatever you're putting in, you just times it by 3 and then add 2. So whatever result I've got, I just times it by 3 and then add 2. So there's my composite function. It's basically inserting g into f. So I've inserted the x squared add 4 into where the x is in function f. So put in one function inside the other. As long as you do it the right way round, you're going to get the right answer. Now this one I am going to expand the bracket just so that I can simplify it a little bit. So if I expand the brackets, I'm going to get 3x squared add 12 add 2. which of course then I'm going to write as 3x squared add 14. Okay, let's move on to part B. Now part B says gf of x. So this time the letters f and g have been swapped over. So this time I need to perform function f first. Okay, so that part needs to be done first. So f of x, I can simply copy straight from the question. F of x is 3x add 2. So I've done the f part. Next I need to do function g. So I need to take what I've just written down and put that into function g. Now looking back to the question, function g tells me that whatever I put in, I need to square it and then add 4. So whatever I put in, I need to square it and then add 4. So there's the function gf of x. You could, if you wanted to, expand this one. I think that one perhaps you could leave in bracket notation. But if you wanted to expand it, what are we going to get? We're going to get 9x squared plus 6x plus 6x, which would be plus 12x. And then plus 2 squared is 4. We're going to add the other 4 straight on, plus 8. So comparing our two answers, you can see that they're not the same. fg of x was 3x squared add 14, and then gf of x was 9x squared add 12x add 8. So you can see that they're very different answers. So when you swap the letters around, you do not get the same function. I'm going to go through C and D on the next slide. So moving on then to part C. Part C asks us to find the function f squared of x. So what this means is that we need to perform f of x, and then we need to perform f again. So f squared is like an f and then another f. So looking back to the question, f of x was 3x add 2. So if I just write that straight down, I've performed one of the f of x's. That's the first f of x done. Now I need to perform function f again, which means that I need to substitute this into function f. So thinking about what function f does, it says whatever you put in, you times it by 3 and then you add 2. So whatever you put in, you times it by 3 and then you add 2. So hopefully you can see there that function f has been performed twice. Taken first of all x on its own, times it by 3 and added 2. And then that whole result, I've done exactly the same thing again. I've times it by 3 and then added 2. So it's like inserting function f into itself. Just going to expand the brackets then to tidy it up. So that's going to be 9x add 6 add 2, or 9x add 8. The last part of this example then, part D, the values of b such that fg of b equals 62. Okay, so first of all, let's think back to part A where we did fg of x. When we did fg of x, we started off by doing g of x, which was x squared add 4. And then we did function f to that, which means that we times that by 3 and then added 2. And then, if you remember, I said you could either leave it like that or you could expand it if you wanted to. So let me just expand it. 3x squared, add 12, add 2, which would be add 14. So this was the function there. fg of x was 3x squared add 14. So let me just write that here neatly. Oh, that's wrong. Let's try again. fg of x equals 3x squared add 14. So that's just using my answer from earlier on. Now in this question it says fg of b has to equal 62. So that means when I change the x's to b's, so when I substitute b into this composite function, I need the answer to equal 62. So into that function that I've already worked out, I'm going to substitute in b with the x's. So I'm going to make that 3b squared plus 14. And when you sub b into this composite function, the answer has to equal 62. So then that just gives me an equation to solve. So let's solve it. I'm having trouble with the pen today. So I'm going to solve this by taking 14 off both sides. So if I take 14 off that, it's going to be 48. Then I could divide by 3, which is 16. And then I'm going to square root. When you square root, remember you can get a positive or a negative answer. The clue was in the question where it asked us for the values of b. So b can equal plus or minus 4. So key things then so far. Composite functions are just ones where you have more than one function being performed. They're always written down in the opposite order to what they are performed in. So fg means that you do function g first and then function f. And f squared is just another way of saying do function f and then do that same function again. Okay, so now I would have a go at some questions yourself based on what we've done so far. So if you have a look on page 42 of your booklet, the exercise there, I would at the moment just do 1, 4, 5, 6 and 7. We haven't mentioned anything yet about domains and ranges, that's coming up later, which is why I've not said do all the exercise. So these ones are just like the examples that we've gone through. So just tackle questions 1, 4, 5, 6 and 7. There are a couple of questions here where you've got 3 functions. So for example, f, g and h. So say for example, you were given 3 different functions. So you were told f of x equals something and g of x equals something else, and then h of x equals something else. If you're asked to perform something like this, f, g, h of x, use exactly the same method. It's just going to take a little bit longer. So on this one you would do h first of all. So just write down whatever h is. Then you would perform function g to that, and then you would perform function f to that. So they work in exactly the same way if there are 3 functions as if there were 2. Just work backwards, so do h first, then g, then f. So you're working backwards to get them done in the right order. So pause the PowerPoint now, have a go at those questions, and then after you've done those, next we're going to move on to talking about domains and ranges. Okay, so we're now going to come on to the part that I think is more difficult for composite functions, and that's finding the domain and the range. The domain is usually quite easy to find, but the range is not always as straightforward. So in this example, we've got 2 different functions f and g. F of x is equal to 2x add 1. So whatever you put into that function, you're just going to double it and add 1. We're given this time a domain, so the domain is 1, 2, 3, 4 and 5. It's in those wiggly brackets. So if you remember, that means that we're just including those 5 numbers, 1, 2, 3, 4 and 5, nothing more, nothing less. So they're the only numbers that we're allowed to put into function f. We're then given the second function g of x, and this one is x squared. So whatever you put into this function, you just got to square it. And for this one, the domain is any real number. So as long as x is a member of the set of real numbers, then you're allowed to put it into function g. So basically we can put any real number we want into function g. Now the question is, find the domain and the range of gf of x. So that's where our composite function comes in. So that means, remember they always appear in the wrong order, we've got to do function f first, then we've got to do function g to that, and then the domain and range are going to be what numbers do we put in and what numbers do we get out. So one way of doing this would be to draw a picture. So I'm going to build up a picture now of what would happen in this composite function. Now I'm going to start off with the function f, because remember I need to do f of x first. So because I'm doing f of x first, I look at what numbers I'm allowed to put in to f of x, and that was 1, 2, 3, 4 and 5. So my first circle, I've drawn there the domain of f, 1, 2, 3, 4 and 5. So they are the numbers that I'm allowed to put in, and I'm going to perform function f to each of them. So individually, I put them into function f. So if I put 1 into function f, double it, add 1, it gives me an answer of 3. If I substitute 2 into function f, then that gives me an answer of 5. And if I substitute 3 in, it gives me an answer of 7, etc. So I've started with 1, 2, 3, 4, 5. I've performed function f first of all, and at the moment now I've got 3, 5, 7, 9 and 11. So I've done the f part, put the domain in, and I've got the range of f out. Now that I've done function f, I now need to do function g to that. So whatever numbers I've got at the moment, which are 3, 5, 7, 9 and 11, I now need to do function g to those. So those now become my new domain for g. So I put those into function g, which if you remember said just square it. If I square each of those numbers, I get 9, 25, 49, 81 and 121. So those are the numbers that have come out when I've squared 3, 5, 7, 9 and 11. Now these numbers are the range of gf or gf of x. Remember that range is just another word for output. So these are the numbers that I've got out when I've performed function f first and then g second. So finally, let's look at the whole function, so the whole picture. If I wanted to write down the overall domain and the overall range, so that means the domain and range of the composite function, the whole thing, I need to look at what numbers did I put in at the very start and what numbers did I get out at the very end. So at the very beginning, I put in the numbers 1, 2, 3, 4 and 5. So this is the domain of the composite function. The domain of f of x, the domain of gf of x is 1, 2, 3, 4 and 5. Then for my range, what numbers did I get out at the very end? I can see that the range of my composite function is 9, 25, 49, 81 and 121. So these are my answers for the domain and range of the composite function. Notice that these numbers in the middle, the 3, 5, 7, 9 and 11, they're not part of my final answer. They were just numbers that we went through during the process, but they're not at the very beginning, they're not at the very end, so they're not in my final answer, but obviously they were useful. So this is the last example that I'm going to go through with you today. It sort of brings together everything actually that we've done so far on functions, and this one's actually an exam question. So we've got two different functions, f and g. F of x is x squared minus 19, so whatever you put into that one, you square it and take 19 off. And then g of x is 1 minus a half of x. So for that one, you input, you half it, and then you subtract it from 1. Now we're given the domains for each of them. So the domains of f and g are minus infinity to 0 and 6 to infinity respectively, which means that this one is the domain for function f and this one is the domain for function g. So for this question, the only numbers that we're allowed to put in to function f is anything between minus infinity and 0. The curved brackets means that we're not allowed to include those numbers. Obviously you can't include minus infinity anyway, because it's not an actual number that we could reach. But the 0 bit is important. You can put down any number that is below 0, but not 0 itself. And then likewise for the g function, our domain is 6 to infinity. So for this question, we can only put numbers into g if they're between 6 and infinity, not including 6. So anything higher than 6, all the way up to infinity. Now in part A, we're asked to write down the range of f and the range of g. So these are just individual functions, f and g separately. So this is like what we learned about last week. Then when we get on to parts B and C later on, they are where the composite functions come in, the f, g. So that's what we've been studying today. But first of all, let's have a look at part A. We've got to write down the range of f and the range of g. Let's start off with f. Now a couple of the tips that I taught you last week for finding the range are, first of all, work out what happens when you put the numbers from your domain into the function. So for example, for function f, our domain is minus infinity to 0. So if I think about what f of minus infinity would be and what f of 0 would be, then that might help me to work out what the range is. And then the other thing to do, which is really helpful, is to sketch a picture of the graph. So first of all, f of minus infinity. Now, technically speaking, what I'm writing here is a little bit naughty because I'm substituting in minus infinity as if it was a number. And obviously that's naughty because minus infinity is not a number. But imagine for a moment that it was. If you took minus infinity and you put it into this function, you'd have to square it and then take away 19. So first of all, imagine squaring minus infinity. Well, when you square a negative number, it becomes positive. And when you take a very, very large number and you square it, it becomes even larger. So if you squared a number that was infinitely big, it would try to become even bigger, but it would definitely still be infinitely big. Then if you subtracted 19 off it, because that number was infinitely big, subtracting 19 off it is not going to really change it very much, so it's still going to be infinitely big. So when I put minus infinity into the function, it's going to give me a number that's infinitely large. Same thing then for 0. This one's obviously easier to work out. If I sub 0 into the function, 0 squared, take away 19 is minus 19. The next thing to do then would be to do a sketch of the graph if you can. Sometimes you're given a function that you might not know what it looks like, but this one's a nice easy one. We obviously know what this graph looks like. It's the quadratic U shape that's slid down to minus 19. Remember the domain is minus infinity to 0, so that means that along the x-axis I only draw the graph that has x coordinates between minus infinity and 0. So when I start to draw this U-shaped curve, I'm having trouble with the pen again, bear with me. There we go. So when I start drawing the U-shaped curve, I'm going to stop when I get there, because along the x-axis I'm only going from minus infinity up to 0. So when I hit 0 on the x-axis, I need to stop drawing. So that number there is minus 19. Now looking at the graph that I've drawn, to work out the range I need to look at the y-axis and think, right, what's the lowest value it reaches and what's the highest value it reaches? Well, the lowest point on this graph is obviously at minus 19. And then because this curve would continue going up and up and up, on the y-axis it would in fact go to infinity. So my range for function f is from minus 19 up to infinity. So I'm going to use the bracket notation. I know that infinity always has a curved bracket, so I don't need to think any more about the brackets for infinity. But for the minus 19, I need to think about what bracket to put on it, a curved or a square. So I need to decide, would my graph actually reach that point where it goes through the y-axis at minus 19? Well, if I look back at the domain, my x values went up towards 0 but didn't quite hit 0, because remember 0 had that curved bracket on it. So as I'm coming along this graph from left to right, I'm getting closer and closer and closer to 0 along the x-axis, but I never quite hit it, which means that I never quite hit that minus 19 on the y-axis. So I'm going to put a curved bracket on the minus 19. So there's my answer for the range of f. Now I'm going to do the range of g, and I'm going to use a similar sort of method. So for g, the domain was 6 to infinity. So I'm going to work out g of 6 and then g of infinity. So let's start with g of 6. If I put 6 into the function, it would be 1 minus half of 6. So that's 1 minus 3, which is minus 2. Next, I'm going to work out g of infinity. Again, the notation I'm using here is a bit naughty. We can't really substitute infinity into a function because infinity is not a number. But we can use infinity as a concept, an idea, and think if we put a very, very large number into this function, what would it look like? So if I put infinity, or think of it as a very, very large number, into this function, first of all, I'd have to half it. Well, if you take an absolutely enormous number and you half it, it's still absolutely enormous. Then we would subtract that from 1. So imagine starting from 1 and then taking away an absolutely massive number. You'd be way down in the negatives. And because that number is colossally big, infinitely big, you'd be so far down in the negatives, you'd be heading towards minus infinity. So if you put an infinitely big number into function g, you'd get an infinitely small answer. Next, I'm going to try and draw the graph. Like I said earlier, sometimes you won't know what the graph looks like, but if you can draw the graph, it can be really, really helpful. Now this one, I can draw this as a graph. This is just a linear graph, a straight line graph. So if you imagine it written as y equals 1 minus a half of x, then that's in the form y equals mx plus c. I can see that the gradient is minus a half, and I can see that the y-intercept is 1. So it would go through the y-axis at 1, and it would have a gradient of minus a half. I'm just going to draw that as a dotted line, just to begin with. Now I need to work out which part of this graph I actually need. We're looking at the domain. I'm only looking at x coordinates between 6 and infinity. So I'd find where 6 is on the graph, and I only actually need from 6 to infinity, so this part of the graph here. Now you might be wondering, how did I know that 6 was there? How did I know that 6 wasn't where it cuts through the axis, or why was 6 not to the left of where it cuts through the axis? Well, I've done a bit of forward thinking in my mind, and I've worked out where that line would cut through the x-axis. And remember, to do that, you'd sub in that y is 0. So because I've drawn the line y equals 1 minus a half of x, if I wanted to know where that line goes through the x-axis, I would sub in y is 0. And then when you solve that, you end up with an answer of x equals 2. So the dotted line that I drew originally would go through the x-axis at 2. But then remember that we only needed to draw the line from 6 onwards, which is why I've started here now at 6 and gone to the right. So that dark red line there is the part of the graph that I'm interested in. Now I want to write down what the range of g is. So I'm looking at that part of the graph in bold, and I'm working out what is the lowest y coordinate and what's the highest y coordinate? Well, the highest step that the graph ever gets is here, so I need to work out what that number is. And then how low does the graph go? Well, because that line would continue on, going down and down and down forever, and the graph actually would go down to -infinity on the y-axis. So, putting that into brackets then, you always put the lower number first when using bracket notation. So -infinity would go first, curved bracket always for infinity, or -infinity. Now then, how high does the graph get? Well, the highest point of the graph is when x is 6, and I've already worked out what that y coordinate is because we did it here. I worked out that g of 6 was -2, so that's the y coordinate there, -2, so that's the highest point the graph reaches. So you can see that the work I did earlier did actually give me the two answers that I needed, from -infinity up to -2. Last thing I need to decide here then is what type of bracket to put on the -2. Well, going back to the domain, the 6 had a curved bracket on it, which meant that I didn't include the number 6. I never quite reached the number 6 on this graph, which means that I'm never quite going to reach the -2 either. So curved bracket there on -2. I didn't do a very good job of that. Let's try that again. There we go. So part A now is done. Let's move on to part B. Write down the domain and range of fg. So now we're getting into the composite functions, which is what we're really studying today. Fg. Remember that the letters are always written down in reverse order. So for fg, I need to perform function g first, then function f, to make sure that we get things in the right order. So I'm going to draw this as a picture, so we can visualize what's going on. So I start off with some numbers, and I'm going to perform function g first of all, which is going to give me some outputs. Then I perform function f to those, and that's going to give me another set of outputs. So this is what's going on in this composite function. We're performing function g first and then function f. So let's go back to the beginning of the picture. I'm performing function g first. So I need to think about what am I allowed to put into function g. Well, they told us this in the question. We're only allowed to put numbers into g if they're between 6 and infinity. So anything between 6 and infinity can go into g. And next I need to find out what would come out of that. Well, we've worked that out in part A. So this is the reason that part A is in this question, because I now need to know what could come out of function g. Well, we worked out earlier that the range of g was -infinity to -2. So those numbers have come out of g. Now we carry on with the picture. So now I've got to perform function f, but only to these numbers. Now it's always worth checking, are you allowed to put those into f? So look back to the question. Are you allowed to put numbers between -infinity and -2 into function f? The answer is yes, because if we look back to the domain of f, you're allowed to put anything from -infinity to 0. So from -infinity to -2 is absolutely fine. So we can put those into f. Now I need to work out what I would get out. Now earlier on, we worked out the range for f was -19 to infinity. But that's not what I'm going to write here, because -19 to infinity was the entire range for f if you put all of the domain in. But now we're only putting from -infinity to -2. So I need to work out what I would get if I put -2 into function f. So as a side note, let's work out what f of -2 would be. If I put -2 into function f, square it, take away 19. So that's 4 take away 19. That's minus 15. So the output would be minus 15 to infinity. So notice that that is different to what we had earlier. So maybe after I finish going through the example, if you're not quite sure why that's different, pause the PowerPoint, listen through it again, make sure you can get your head around where that minus 15 has come from. Right, okay, so let's go back to the beginning and just recap what's happened. We're doing the composite function fg, which means we perform g first then f. So I performed g first. I thought carefully about what am I allowed to put into g, and after I've performed g, what will I get out? Then I performed function f, so I put these numbers into function f, and I've worked out what will I get out. The question was, write down the domain and the range of this composite function. The domain will be what did we put in at the very beginning. The range will be what did we get out at the very end. So let's write down our final answers. The domain of fg is 6 to infinity. And the range of fg is minus 15 to infinity. Okay, very last bit of the question then, C part 1. There was a part 2 that I've cut off because we haven't studied that bit yet, but C part 1 we can do. Write down an expression for fg of x. So we've done some questions like this already today. Fg of x. So we perform function g first. So I'm just going to write down what that is. It's 1 minus half of x. I haven't got a number to sub in. It wants me to keep the x's. So looking back to the question, 1 minus a half of x, that's function g. So I've done function g, that's done. Now I've got to do function f to that. So I've got to substitute that into function f. So looking back at the question, what function f says, whatever you're putting in, it says to square it and then take off 19. So I'm going to put a bracket there, square it and take off 19. And that's it, that's my answer. That's what fg of x is. Yes, you could expand the bracket if you wanted to and simplify, but I'm just going to leave it like that for now. So I've done function g and then I've put that into function f. Remember that if you do this the wrong way round, you're going to get a totally different answer. If you put f into g instead of g into f, you're not going to get the right answer, so you have to do them in the correct order.